In 2023, a team of veteran aerospace engineers gathered at a conference in Houston. The topic? SpaceX's Starship. One by one, they laid out their concerns. Too complex, unnecessarily large, won't survive Mars re-entry. The room buzzed with skepticism. Meanwhile, at SpaceX headquarters in Hawthorne, California, another Starship prototype was taking shape. The world's largest rocket, standing taller than the Statue of Liberty, gleaming in stainless steel. A rocket that breaks every conventional rule in the aerospace handbook. The debate rages on. Robert Zubrin, president of the Mars Society, warns of deep craters forming under Starship's powerful engines during landing. Peter Beck, Rocket Lab's founder, questions the very economics of Mars missions. Even NASA veterans scratch their heads at the complexity of orbital refueling. But here's what's fascinating. While some of the most experienced minds in aerospace raise red flags, others see Starship as nothing short of revolutionary. Dr. Ali Bramson from Purdue University calls it a complete game changer for solar system exploration. NASA scientists are already planning experiments that were impossible before, like sending full-size drilling rigs to Mars. Today, we're diving deep into this controversy. We'll examine why some of the brightest minds in space exploration are divided over Starship, what the critics are missing, and why this massive rocket might just rewrite the rules of space travel. Welcome to Elon Musk 24 Hours. Let's dive right in. The story of Starship begins with a question that haunted Elon Musk for years. Why aren't we already on Mars? It's a question that led SpaceX down a path that traditional aerospace companies considered impossible. But to understand why Starship has become such a lightning rod for controversy, we need to look at what makes it fundamentally different. In the halls of NASA's Johnson Space Center, there's a full-scale model of the Apollo command module. It's tiny, barely big enough for 3 astronauts to squeeze into. Now picture Starship. Its crew compartment alone is larger than the entire International Space Station. When Robert Zubrin first heard about these dimensions, he thought it was a mistake. It's like building a cruise ship to cross the Atlantic when we barely have working sailboats, he said in a 2022 Mars Society conference. But here's where the story takes an unexpected turn. That massive size isn't just ambition, it's necessity. And it all comes down to one revolutionary idea that SpaceX refuses to abandon: in-orbit refueling. Think about this for a moment. Every other rocket in history has been designed to make a single trip with all the fuel it needs. Starship, it's designed to be a cosmic gas guzzler, meeting up with tanker ships in orbit to fill up its tanks. It's like building a network of gas stations in space. When Peter Beck from Rocket Lab heard this plan, he was skeptical. Tens of thousands of launches, he said, shaking his head. The logistics are mind-boggling. But what critics like Beck might be missing is that SpaceX isn't just building a rocket. They're building an entirely new infrastructure for space travel. Those gas stations in space aren't just for Mars missions. They're the key to everything SpaceX wants to do, from lunar landings to satellite deployment. Dr. Jennifer Heldman from NASA Ames Research Center puts it into perspective. With Starship, we're not just sending better cameras to Mars, we're sending entire laboratories. Her eyes light up when she talks about the possibilities. Imagine having a drilling rig that could bore a kilometer deep into Mars's surface. We could finally answer questions about subsurface life that have puzzled scientists for decades. But the controversy doesn't end with size and refueling. There's the matter of the hull. Stainless steel, like something out of a 1950s science fiction magazine. Traditional aerospace engineers were shocked. Modern rockets are built with advanced carbon composites, not metal from the industrial age. Yet SpaceX's choice was deliberate, and it reveals something crucial about their approach to space exploration. Wayne Hale, who managed NASA's Space Shuttle program, explains it best. The genius isn't in using advanced materials, it's in finding simple solutions to complex problems. Stainless steel is cheap, easy to work with, and surprisingly good at handling the extreme temperatures of spaceflight. When coming back from Mars, that steel hull might be the difference between a successful landing and disaster. The challenges don't stop there. Landing on Mars presents problems that even SpaceX's critics might be underestimating. Robert Zubrin's concern about engine plumes creating craters isn't just academic, It's a real problem that needs solving. But SpaceX's solution isn't to make the rocket smaller or the engines weaker. Instead, they're developing new landing techniques and considering the possibility of preparing landing sites on Mars before Starship arrives. This brings us to one of the most contentious points, the economics. Peter Beck's skepticism about the Mars mission's commercial viability touches on a crucial question. How does SpaceX plan to pay for all this? The answer lies in their strategy for low Earth orbit operations. Those same starships designed for Mars will earn their keep launching satellites, servicing space stations, and potentially even carrying passengers on suborbital flights. Let's talk numbers for a moment. A traditional rocket launch costs around $150 million. SpaceX's Falcon 9, with its reusable first stage, brought that down to $65 million. But Starship? SpaceX aims to get the cost down to just a few $1,000,000 per launch. It sounds impossible, but they've done the math. With full reusability and rapid turnaround times, each Starship could fly hundreds of times, spreading the manufacturing costs across multiple missions. Dr. Ali Bramson from Purdue University sees beyond the numbers. Starship isn't just about making space cheaper, it's about making it accessible, she explains. When you can send 100 tons to orbit for the price of sending 1 ton today, you fundamentally change what's possible. The impact on science could be revolutionary. Professor James Heater from Brown University points out that current Mars missions are limited by mass constraints. Every gram has to be justified, every instrument miniaturized. With Starship, scientists could send backup equipment, redundant systems, even multiple versions of the same experiment. It's the difference between sending a pocket calculator and a supercomputer, he says. But perhaps the most compelling argument for Starship comes from NASA itself. When selecting a lunar lander for the Artemis program, they chose a modified Starship despite the risks and uncertainties. Why? Because sometimes the biggest risk is not taking one at all. The reality is that space exploration has always been about pushing boundaries. When Kennedy announced the Apollo program, many thought it was impossible. The same was said about landing rockets vertically, yet SpaceX made it routine. Now, as we stand on the brink of becoming a multi-planetary species, the questions aren't just technical, they're existential. Wayne Hale puts it perfectly. Yes, Starship is complex. Yes, it breaks with tradition. But so did every major advancement in spaceflight. The question isn't whether it's different from Apollo, it's whether it can take us where Apollo never could. The critics aren't wrong about the challenges. Building a rocket this size, developing orbital refueling, landing on Mars, these are monumental tasks. But they might be wrong about something more fundamental, the assumption that these challenges are insurmountable. SpaceX's approach to Starship reflects a deeper truth about innovation. Sometimes you have to change the rules of the game entirely. They're not trying to build a better rocket. They're trying to build a system that makes spaceflight as routine as air travel. It's ambitious, perhaps even audacious, but that's exactly what space exploration has always been about. The debate over Starship isn't just about engineering or economics, it's about vision. While some see an unnecessarily complex system, others see the first steps toward humanity becoming a spacefaring civilization. Dr. Heldman summarizes it best. Starship isn't just another rocket. It's a testament to human ambition, a bridge to the stars, and possibly our best chance at becoming a multiplanetary species. As Starship continues its development journey, one thing becomes clear. Whether it succeeds or fails, it has already changed the conversation about what's possible in space exploration. The question is no longer if we'll reach Mars, but when and how we'll build a sustainable presence once we get there. This isn't just about proving critics wrong or validating supporters. It's about expanding the horizons of human achievement. Every test flight, every improvement, every setback and success adds to our understanding of what it takes to become a spacefaring civilization. And in that light, perhaps Starship's greatest contribution isn't technical at all. It's showing us that the impossible just might be possible after all. As we've seen today, Starship represents more than just another rocket program. It's a bold reimagining of what's possible in space exploration. From its revolutionary in-orbit refueling system to its potential for transforming Mars exploration, Starship challenges our assumptions about the limits of human achievement. The debates will continue, engineers will raise valid concerns, scientists will dream up new possibilities, and SpaceX will keep pushing forward. But one thing is certain, the journey to Mars has already begun, not just in the hardware being built, but in our collective willingness to tackle the impossible. Speaking of tackling the impossible, I'm working on an in-depth analysis of Starship's orbital refueling system. If you're curious about how SpaceX plans to build gas stations in space, drop a yes in the comments below, and I'll break it down in the next video. This is Elon Musk 24 Hours, bringing you the latest developments in space exploration and innovation. If you found this analysis valuable, hit that like button and subscribe to stay updated on Starship's journey to the stars. Share this video with someone who's passionate about space exploration, because sometimes the best debates start with a simple conversation. Until next time, keep looking up. The clock is ticking at Starbase, Texas. Just 2 weeks after Starship's 7th flight shook the skies, SpaceX is already gearing up for their next historic launch. Flight 8 isn't just another test. It's a crucial step toward making space travel routine. Breaking news from the FCC reveals a launch window starting February 24th, 2025. With post-flight analysis underway and modifications being implemented, SpaceX teams are racing against time. Ship 34 is receiving its engines. Booster preparations are in full swing, and Pad B's construction is reaching new heights with the successful installation of its massive mechanical arms. Meanwhile, NASA's Artemis program faces critical decisions, and Japan celebrates a major milestone in their space program. Today, we're bringing you exclusive coverage of these developments that are reshaping humanity's future in space. This is Elon Musk 24 Hours. Let's dive right in. The race to Flight 8 is heating up, and SpaceX isn't wasting a single moment. The echoes of Flight 7's engines have barely faded, yet the teams at Starbase are already pushing boundaries. This isn't just about launching another rocket. It's about proving that rapid reusability isn't just a dream, it's our new reality. The Federal Communications Commission has just dropped a bombshell. Flight 8's operational window opens on February 24th, 2025. But here's what makes this timeline fascinating. It represents a turnaround of just over a month since Flight 7. In the world of the world's largest rocket system, that's unprecedented speed. The window extends through August, but SpaceX's track record suggests they won't need nearly that long. Behind the scenes, a symphony of precision engineering is playing out. Ship 34 is undergoing final preparations, its Raptor engines being meticulously installed after passing rigorous cryogenic testing. The roads of Cameron County tell their own story. A planned closure on February 4th hints at the imminent transport of either Booster 16 or Ship 34. These aren't just routine moves. Each transport brings us closer to the next giant leap. But let's talk about what's really at stake here. The post-Flight 7 analysis has been intense, with teams working around the clock to understand every detail of the previous mission's shift failure. When rumors surfaced about potential shortcuts in the S-33 check process, Elon Musk himself stepped in to set the record straight. This wasn't about rushed procedures or cut corners. It was about facing and overcoming the genuine technical challenges that come with pioneering technology. The FAA's involvement has been transformative. They've streamlined their procedures, recognizing the need to balance safety with progress. This isn't just bureaucratic improvement. It's a sign that the entire aerospace industry is evolving to keep pace with SpaceX's rapid development cycle. At Starbase, the landscape is changing daily. The launch system stands ready, having emerged relatively unscathed from Flight 7. But it's not just about what's visible. It's about the countless hours of inspection, refinement, and enhancement happening behind the scenes. The flight termination system is being upgraded, the payload dispenser modified, and the hot staging system refined. Each change, each improvement, brings us closer to reliable, routine access to space. And then there's Pad B, a testament to SpaceX's unwavering ambition. On January 27th, History was made as the massive Mechazilla arms were hoisted into place. The scene was breathtaking. Massive cranes carefully positioning the chopstick carriage, engineers working with precision to secure these enormous structures. But this isn't just about building infrastructure. It's about creating the foundation for a new era in spaceflight. The chopstick system's installation is just the beginning. Teams are now focused on extending the arms through careful welding, installing complex